Hey guys, my name is Luke, and today I'm going to be giving you a short rundown on how to use Genome. Now, Genome is a pretty cool plugin which allows you to basically clone your objects and have them appear right in your hierarchy, your object manager, I should say, over here. And you can see them, and with some Espresso, you can manipulate all your clones so that you can do some pretty complex setups without ever having to convert your cloner and get rid of the proceduralness that a cloner provides. So to start out with, I've got a normal cloner, and even though it's named Genome Cloner, I gotta erase that. This is just a standard cloner object, and it's cloning this null object, which has 3 items in it. We have a light, which is deactivated right now. We've got a bend deformer, and the bend deformer is over a cylinder. And this cloner is set up with a grid array with count of 12 lengthwise and 2 on Z, or deep, 2 deep. And if I go to my camera view, you can see this is a very simple animation. We're just kind of zooming through, or just like moving through these columns. And for the sake of example, let's say that my boss had said that we were going to try to turn these columns into sort of like this crazy Disney adventure, you know, with the walls come to life and whatnot. So we want these columns to be able to do some dancing, right? So if I go to my bend deformer and I turn my strength to one side or another, you can see we got this pretty cool wavy, jumpy movement. So they're kind of like little noodles almost. But as you can see, when I adjust my bend deformer, all of them are being adjusted at once. We can't, we don't have any kind of control over, do we want just this one to move, or if we want the ones in the back to move. And because it's in a cloner object, we could set an animation, then go into our effectors and maybe do some sort of time offset with our effectors, but then we're still stuck using the same animation for each of the columns. So we want to have a lot of variety in that. We need to switch it up. So what we can do is we can use Genome to accomplish this for us. But in order to do that, we have to open up Genome, and we have to bring our cloner into it. So without any further ado, I'm going to move these elements to the lower part of my object manager, and I'm going to click on my Genome icon right here. And if I hide my cloner for a moment, make that invisible, you can see that once I've brought in Genome, we have this little circular array of some null objects. I'm going to zoom in here. As you can see them right there. And if I open up Genome, you see we have 4 different items. At the top, this slot is where our reference object will be. This is the object that normally resides underneath our cloner object. So in other words, this is where we put the object that we want to clone. The next object is the Genome cloner, and this is where we get to control our clones, or at least this is the first stop for our control in our clones. So if I go in here, and I can go in and adjust the count, and you can see these are the null objects that's currently being cloned right now, sort of a representation of where the final clones will go. And if I twirl down our Genome cloner, you can see this is the reference null that's being used as a example right now. Our next section is called doubles, and this is a fracture object. And if I open this up, you can see that these are null objects as well, but you can see that they're actually clones or duplicates, or you could even say they are doubles of the original object right here. You can see that because they have the same name. And yeah. The next object just has a couple lines here. These are some background elements for the plugin, so you can ignore them, but just keep them where they are. One final thing to note is that the order of these objects within the Genome hierarchy is quite important, so you do not want to be moving them around and shifting their position. If push came to shove, it'd be better just to create a new Genome object so you wouldn't have to remember where everything goes. So now that we have that, when it comes to our scene, what we really want to do is actually move our cloner into the scene. We've already spent all this time creating this setup. It'd kind of stink if we had to go through again and click on our Genome cloner and then try to go to grid array and try to set up everything exactly like we had it. So what we can do is we can go into Genome and use some built-in functions to import our old cloner and use it as our new cloner. So we can go into our Genome header and go into the setting Convert Pre-Existing Cloner. So I'm going to twirl that down, and we can see we have a spot where we can drop in our old cloner, just like that. And then all we need to do is hit Convert, and it doesn't really look like anything happened. And that's because, for some reason, our Genome cloner is visible. Because when it imported the cloner, our old cloner had the traffic lights off. So once we turn these on, there we go, now we're actually seeing something. But just to make our conversion process final, we're going to go into our Genome header again, go into the main setting, and here we have an option for update. I'm just going to click that once, and that's just going to update the scene, and it's going to make sure that everything is doing what it's supposed to be doing. Now, as you can see, we also have an option here to solo source object, and if I click that, you can see that the original object is soloed, so if we need to go back and make some adjustments to our original object, we can. Here, and as you can see right up here, here's where our cloned object, our source object, got moved to. Again, it's right the first slot in Genome's hierarchy, and so I can, move my light around. I could adjust the cloner or adjust the cylinder if I wanted to. Then once I'm done, I can unsolo the source object, and I'm just going to hit update. And as you can see, the lights moved up to replicate the changes I had made to my source object. So we know that the object we want to manipulate is our cylinder, and as we can open up our doubles fracture object, you can see that we have all our cylinders right here. Here's all the cloned objects in our scene. And I can choose this one randomly, and I could select the cylinder, which is that cylinder right there. So you can see that each one of these is actually physically in our scene. And if you don't want to be navigating your clones all untwirled like that, if you twirl this one back up and hit update, you'll see that these will all adjust to follow. Since we know that we want to adjust our cylinders, what we need to do is we need to first of all create an Espresso window. And you might think, well, why do we need to go into Espresso? We could do this by hand. I could open up this one particular object and maybe go into this bend deformer and adjust his strength like that. And you could do that, but the problem is that when we go back into our Genome header and we hit update, the changes are going to be gone. And the reason is that when we hit update, what's happening behind the scenes is all of these objects within our fracture object are being deleted and then recreated again. So all those changes that went into it that we put in by hand are going to be gone. So what we need to do is we need to create an Espresso window and be able to go through each of these, to iterate through each of these bend deformers and be able to adjust them outside of the doubles fracture object. Sounds a little confusing, so let's actually just do it and you'll see it happen right in front of you. So I'm going to open my Espresso window. You can see that it's blank right now. We're going to go back to our Genome header, and we're going to go into a section called Create Espresso. And we have a couple spots here to drop things in. So the first one is Object to Control. So what we want to do is, since we want to adjust our bend deformers to start off with, we go into our source object, not into any of our doubles, right, but into the source object, and we drag the object that we want to control. So I'm going to drag in the bend deformer. Now we have a spot for an Espresso tag, so I'm going to drag in the Espresso tag where I want my nodes to be created, and then I hit Create Espresso Nodes. And as you can see, we've got a couple objects made for us. I'm just going to highlight them, right click, and hit Optimize to make the space a bit bigger. And then we'll just spread these out a little bit so we can see what we're doing. Now the first object is a hierarchy object, and that's going automatically set up to go into our doubles and to iterate one by one through all of these bend deformers. So every frame, it's going to go through each of these nulls, it's going to select the bend deformer, and it's going to send it along our Espresso path, and then it's going to leave that one bend deformer and go to the next one, then go to the next one, and so on and so forth every frame. And you can see that the node properties or the hierarchy properties are already set for us. So we don't need to worry about creating our start path and creating our iteration path. Any of that, it's all done for you. One thing to note though is that the hierarchy object is working, because it's a hierarchy object, it's not specifically looking for bend deformers in themselves. It's just referencing whatever object is in that spot within the hierarchy. So if I move the light into that spot, or I move the cylinder into that spot, or moved another object there, the hierarchy object would then be referencing that object, not the bend deformer. So if you make any changes to your original hierarchy in here, you're going to want to go through and generate a new hierarchy object so you can control it. The next object in here is, or the next node in here is the object index node. And that's going to be taking all of these iterations, all of these bend deformers that are being iterated through. It's going to send them into here, and it's going to assign each of them an index, or an identification number, basically. We can then use this identification number later on within our setup to control them, to have specific things happen to specific clones, which is all cool. The next thing I want to do is I want to go to my bend deformer node. You notice that that's already been created for us as well. I'm going to click on our blue or input ports and choose object. And I'm going to feed this object port right into our instance node. The next thing I want to do is I want to open up our on button right here. And the on button is sort of like a power switch. So if I turn the power switch on, this means that any changes I make to this node, if I open up another setting and made a change to that setting, as long as this on switch was on, any of the instances coming in here would have, any of those bend deformers would have those changes applied to them. If this was off, those changes would not be applied because the node is off. So we could use that and we could hook it up with our index parameter right here. And what we could do is we could create some sort of setup so that maybe if only when index 4 came in through here, that the changes made over here would be applied only to index 4. Maybe we could set it up for all those nodes greater than index 4. And so we can easily do that, and I'll be showing you how to do that in just a second. So finally, what we want is, we actually want, if we go into our bend deformer, we want the strength parameter right here. So we go into bend, go into object properties and strength. It's right off of our capture window, so let's move this up. Right there. So now I have all three. I can start figuring something out. So I'm going to go in and create constant node and feed that into strength right here. And if I start clicking this, you can already see that we're getting some motion. And the reason this is such a strong motion, I mean, you'd think that, wow, our bend deformer, you know, whoa, so you see it's even stranger than we thought. This shows 171, and this shows -3, so what's actually happening? Well, this is unrelated to Genome, but I might as well discuss it. Whenever we use degrees in Cinema 4D, behind the scenes, it's actually using radians. So we see degrees because we understand degrees better than most people understand radians. So it kind of allows us to use degrees over here, but behind the scenes it's using radians. So when we're feeding in our constant node into there, we're actually feeding in, when we feed in a 1, we're giving it 1 radians, then we do 2, it's 2 radians, 3 radians, so on and so forth. So because we want to have a little bit easier control of this that makes a bit more sense to our degree-oriented minds, I'm going to go into make a new node, and calculate, and it's called degree. So what I'm going to do is I'm going to turn my degree node, turn it into degrees to radians. And what that will do is that will make this constant node work a bit more as we would expect. So I'm going to adjust this, and you can see, here we go, we're starting to see some motion, which is pretty cool. But let's say that we only want this to happen to only a certain set of nodes. This is where our on switch comes into play. So I'm going to go in and I'm going to create a go to logic and create a compare node. And what we want to do is we want to let the compare node decide whether these changes we've just made are applied to all nodes or only a specific subset of nodes that we decide upon. So I'm going to hook up input 1 to the index and the output to on right there. So if I go into my compare node, I'm going to keep it right now at equals right there. And what this is going to say is that every frame, remember we're iterating through all of these bend-deformers, they're all being sent through the object index. Whenever the index equals, right here, whenever that equals, we're just going to say 10. Whenever the index equals 10, turn this bend-deformer node on, and then have these changes, which I just removed by mistake, have these changes affect the bend-deformer, or affect the bend-deformer of index 10. So if I go into my constant node, I back up a bit so you can see what we're doing, and start making some adjustments, you can see right at the bottom over here, we're only affecting index 10. But what if we wanted to affect more than just one particular node? Well, that's a piece of cake. I just go into my compare node and change my equals to not equals. So when I set the compare node to 10, like this, and then go into our constant node and start adjusting this, you'll see that all of the other ones, except for number 10, are having that change being made. And I'll give one more example here. I'll go in here and I'll set this to, say, less than or equals to 10. So now all the nodes that are with an index of less than or equal to 10 are going to be affected, and all the other ones aren't. So already you can start to see how what kind of potential this has, where you could create several different sliders and kind of create a pretty elaborate setup so that these two guys are dancing in unison, or these two guys are bending in unison, or something like that. You've got quite a bit of control. So let's look at another problem that I'd like to fix in this scene. And it isn't really a pure problem right now, but when it comes down to render time, and if I had a lot of textures on these items, render time would be slow. And so I'd like to make a couple changes to optimize the scene. For instance, I know that these lights right now are casting area shadows. And so what we would like to have is that the lights that are farther away from the camera are casting soft shadows, which are faster to render, and that the lights maybe closer to the camera are casting area shadows, so that the area right around here looks really good, but the farther away we go, because it's so far away, we don't need it to be as good as right down here. And of course, with such a small scene like this, it probably wouldn't matter. But if we had gone into our cloner, and we had cranked this up to, I don't know, let's bring this up to 1,000. I bring this up to 8. Let's actually do 2,000. As you can see, once I do that, though, my scene is really crawling to a halt, and everything isn't really moving around properly, and for some reason this got to 3,200. We don't want that far away. But this is a slightly different issue. This is because all of our cylinders have the same amount of subdivision right here. It would be really cool, if maybe around the camera, those objects had a very high amount of subdivision, so they look good. But the objects that are farther away had less subdivision, so that we could navigate around our scene better, and that when it came time to render, there wouldn't be as much render geometry. So this again is a perfect thing that we can work on with Genome. So I'm going to move this over in my Expresso setup. And so the first thing we're going to do is let's look at our cylinder. Let's work on that. So I'm going to go into Genome. I want to create more Expresso, and this time I want to control my cylinder. So I'm going to drag that, drop it into Object to Control, bring in my Expresso tag, hit Create Expresso Nodes, and right there at the bottom, you can see our new nodes. Oops. And right now this hierarchy node is set to iterate through all of our cylinders, and it's being fed through, let me just optimize this, it's being fed through our object index node, Try that again. Looks a lot better. And then we have our cylinder node right here. So I'm going to turn this guy on. Oh, actually, I'm going to make the object node 2. That was what I meant to make. And then feed the object port right into the instance port right there. Now what I'm going to do is I'm going to create a new null object. I'm going to call this, what do I want to call this? I'm just going to call it reference point. And I want to, once I rename it there, now what I want to do is I want to move this. See how slow everything is. This is why we need to optimize it. I'm going to make it a child of the camera object and then zero out everything. And I do have a button for it up here, but I'm going to do it by hand just because it's a tutorial and it's a little easier to see what I'm doing. So now that's in the same spot as the camera is, I'm going to drag it out from underneath the camera. And what I want to do is I'm going to drag this right into my hierarchy right here, or into my drag it into my Espresso nodes, mixing up my terms. And I'm going to open up the global position port right there. What I'm also going to do is I'm going to go into my cylinder node right here, and I'm going to open up the global position port on this one as well. And then what I can do is create a distance node, go into new node, Espresso, calculate distance. And I'm going to put these two ports right in there. So what's happening, every frame, all of these cylinders are being iterated through by the hierarchy node. That's being fed through the object index node, which is assigning them all a number. Then those instances are coming out of here into this cylinder node, where we're getting the global position of each of those cylinders and comparing the distance, or comparing the position to the position of our reference point null object. And then we're actually just finding the distance right here. So if I could put, a constant or maybe like a result node right here, and we won't really get a good result from that. It says 2100 or 2186.16, but we don't know which of these indexes is actually being referenced by that. We just know that one of them is that number. It's actually doing all of them every second or every frame. So now that we know that, we want to somehow use this information to change in our cylinder object, to change these settings, the height segments and the rotation segments. So what I'm actually going to do is I'm going to take the cylinder node and I'm going to create another one. So I just duplicate it. To do that, I was holding down the node, holding down the command key, and then just dragging and dropping. So let me delete this one. I don't need the global position port of this one. And I'm going to keep those two ports, and I'm going to bring in, under object properties, rotation segments and height segments. Now I need to connect my object port right here all the way over to my instance port right there. So let's move these down just so we have a better line of sight. So we have rotation segments, height segments, and move this over here. Now somehow we need to transfer this data from whatever the distance is and turn that into rotation segments and height segments. The perfect tool for that would be the range mapper. So I'm going to right click, new node, Espresso, calculate, range mapper. And I'm going to connect one end of this over here and the other end over here. So let's start with rotation segments. And we're going to say that when the input distance, let's say we'll keep that at 0, and we'll keep the farthest distance away at, it says 2,000, so let's try, let's try 3,000. There. So when the distance is anywhere from 0 to 3,000, it'll be mapped to, since we're doing rotation segments, we want, when it's a distance of 0, we want a high amount of subdivision, so we'll say 35. And when it's farthest away, we want a lower amount, so we'll just say 10. like that. Now, if I highlight, let's see if I can highlight all my clones here, right there. Let's see, we don't see anything happening right now. Let's see if I hit update. We're still not getting anything. Maybe it's because my on switch is not on. Let's see if I click that on, what do we get now? And we should probably turn this on switch on as well. Now let's see what happens. Well, we are seeing something now. If we go over here, wait, okay, because it's so slow right now, let's do a little bit of more simple optimizing by reducing the amount of stuff we have in the scene. So let's make this down to, say, 5 by 5. And let's reduce our distance. Oh, we'll keep the same distances though. And let's update the scene just to be sure. And now you can see over here, right where the camera is and right where our reference point null object is, these pillars, these columns, have a very higher amount of rotation segments in their subdivision. You can see how many there are right up there. But if I move over here farther away, you can see these have much less. In fact, these aren't even enough to make them all the way circular. So what we need to do is let's head back into our range mapper node. And one key aspect of our range mapper node that we need to adjust, which I forgot about, is we need to clamp our two distances. And this way, instead of having these numbers be sort of like a reference on a graph where the numbers could go, you know, if maybe the distance was 5,000, they would go, the output would go all the way down to 2 or to 3. By clamping these two numbers right here, we're saying that if the distance is 3,000 or anything above 3,000, we want it to be 10. And if the distance reaches 0, we want it to stay at 35. We don't want it to go any higher than 35. So we're mapping the range between 10 and between 35. So now we can see that the columns farther away are a bit more subdivided now, so at least they're circular. But the ones closer to have a lot more subdivision right there. And so I could even adjust this to 40, and you can see those have increased. Well, these back here have stayed at 10. I could might even be able to drop this down to a little bit lower. Let's keep 6. So now we have our scene is a bit better. And the cool thing is that I can go in, and if I can drag this reference point, let's say, over to the other side, over to here, let's make this reference point a bit easier to see. There we go. Now we have a little sphere to look at. Now if I go in, I look over here, these are the ones that are highly subdivided. See how much subdivision that has? Versus the ones farther away, much less. And the other thing that's kind of cool is because we're using a range mapper node, we have this graph at our disposal. So I can quickly make 2 points on the graph. I'll make another point right in the middle. So as you can see, by adjusting this knot, I can adjust the fall off of this setting. And this is a very nice feature because it allows you to have complete control over where the subdivision is. Now what I could also do is I could create another range mapper quickly that works in a similar fashion, but this time it works with the height segments. And what I could actually do, now that I think about it, is I could just take this same output right here and have that affect our height settings as So now these guys over here are have a real high amount of subdivision. I mean, look at this guy. I mean, you can see all the height markers all the way through. Very high amount of subdivision, but way over here, a lot less. They've only got like 6 or 7 height divisions. Now, one other thing that I would like to do is if we go into our light settings, right now the light is turned on, you can see that all of these lights are set to an omni-light, but they're also set to an area shadow. And as most people know, area shadows take a lot longer to render than, say, shadow maps. And so it'd be really nice if the area around our camera, maybe these lights had area lights, so that those shadows looked really good. But when we get farther away from the camera, we're really not going to be able to tell the difference between the shadow maps and the area maps. And so I'd like to switch those all to soft shadow maps. Now before we used a range mapper node because the settings that we were changing were a range of numbers, like for instance anywhere from 5 segments to 35. Whereas with the light, these shadow settings are done with single numbers. So none might be 0, shadow maps 1, ray traced or hard 2, area 3, so on. So we need to do something a little bit different. But first, we should probably set up our basic Espresso. So I'm going to open that up, and let's go into our Genome object and drag our light into the Create Espresso right there. Our Espresso tag into Espresso tag. Create Espresso nodes. Here we go. And we can see our hierarchy object is set up to go right to the light, and everything is as it should. So just optimize these to make them a bit bigger. You can read the words. Now let's move this up a bit. Go into our light setting, go to Object, plug the instance node in. Now let's go in and let's see what the actual settings name is. It's under General tab, and it's Shadow. So we go under here, General, Shadow. Now let's just figure out what type of shadow, what the numbers associated with area shadows and with soft shadows are. So I'll go into get a constant node, plug that into here, and let's set this to 3. Now if we go into our doubles section, I'm going to choose a light at random. This has area shadows, as does this one, and this one. So it looks like 3 is our setting for area shadows, whereas our setting for, let's try number 1. Now let's see what they all are. Now they're all shadow maps. So we know that we want the lights for shadow maps to be on a setting of 1, and the area lights to be on a setting of 3. So let's set that part up right now. So since we already have the 1 section set up, let's duplicate this setup right here. Again, I did command and drag to get that. And let's set the object over here. And let's set this constant node to 3. Now we need the on ports. I think we're going to be reusing our, let's actually twirl this up a bit more efficient, our reference point null right there. And we're going to get our global position like we had before. And now we also need to calculate our distance again. So I'm going to keep these 2 light nodes over here. I'm going to make a third one and plug this guy in here. And this guy is just going to be for getting our distance. I delete these other ports because we don't need them. And coordinates, global position. Again, optimize that. Let's move these back a bit. And now we need a distance node like we had before. Calculate distance. I'm going to plug in global position here and the other one here. Move this back a little bit. Since I have this null object already, I'm going to use this to our advantage to provide us with a visual representation of which lights are going to have area shadows and which lights are going to have soft shadows. So I'm going to open this up, and I'm going to get us the radius input right there, or out port. And if I go into my reference point null, I have this radius section right here, and the same one. And if I increase this, you can see we have visual representation right on our screen. So this will be used to show us which lights are in and which lights are out of our sphere of influence. So this is sort of like our fall off map, you might say. So I'm going to right click and bring us in a compare node. So I'm going to plug the first input into the distance port right there, and the second one into the radius port right there. And I'm going to set this to be less than or equals to. And what this is going to do is, remember, we're iterating through each of these lights, and we're calculating the distance from that light to the reference point. And if that distance is less than or equal to the radius, which is the sphere of influence, if it's less than that, we want to turn on the area lights, area shadows on the lights. So now I'm going to plug in this out port to the on port. Now that we have set which lights are going to be area shadows, we need to also set which particular lights will be the shadow mapped lights. And the cool thing is we can use this same setup that we have right here. All we need is one more node. We'll go new node, Espresso, bool, and not. And what not does is it takes an input of either 0 or 1, true or false, and it will output the opposite of that. So whenever this, if we hook it up right here, whenever this is outputting a 1 or true, not will output a false. Whenever this output is false, not will output a true value. And if we plug that right into here, what this is going to do is if we click on any particular light in this scene, let's see if we can find one in particular. So I'm going to choose this light. And this light, as you can see, is outside of the sphere of influence. So we have a shadow map. But, and we're going to close this up. If I move my reference this bigger, well, actually you can see a graphical representation up there on the image. So you can see these squares represent that the light is casting out an area shadow, right? And as I increase this, you can see like this light, as it became within the sphere of influence, it turned into an area shadow. And now I'm going to make this larger and smaller, and you can see that change live. Now what makes this really cool is that if our supervisor wanted to have even more columns, we can very easily go in, right, and change this to 7. And let's go in and update. And this setup works for that as well. And I can even move my reference point null, and you can see these are all changing live. So that is very cool. Well, I think now is a good time to end this basic training session. In the next video, I'll discuss how you can use MoGraph effectors to modify your genome objects and how Genome fits into the whole MoGraph picture. In the video after that, I'll discuss some of the idiosyncrasies of using Espresso within your source object. It gets complicated quite quickly, so if you have any plans to do to place an Espresso tag on your source object or in there, I highly recommend you watch that video because it has some very important information on how to avoid problems. So thanks for watching, and I hope you like Genome.